Alright, so today's video we're going to go over how I manage the thermal masses in the greenhouse and how I use the DS18B20 one-wire digital thermometer temperature sensors to monitor two different tanks, compare between them, and turn the pump on and off when and where appropriate to transfer heat from the thermal mass on top of the stove to the large storage thermal mass. So here we are in SSH. We're logged into the Raspberry Pi 4 in the greenhouse, and we're just going to go ahead and use the Emacs program, which is a great editor when you're in SSH. So we're going to go Emacs, and then we're going to point to the file, which is root, in the root directory, root pump control.py. So this is a Python script. Alright, so just like the previous video, part 16, we talked about importing the system, importing the operating system, and rpi.gpio as GPIO. The rpi GPIO as GPIO lets us manage the interface to the relays through the GPIO ports. The other one I bring in here is term color. This is not necessary, but I find it's really nice when you run the script. When the pump is off, it tells you that in red. When the pump is on, it tells you that in green when you're testing the script. And it's just kind of a nice visual confirmation at a glance. So if you do want to use that, you'll have to install term color. I think it's apt get install term color or Python term color. I'll dig up a link in the description. It's been a while. So let's see, we import the OS, we import the system stuff. You'll need import sys, you'll need import rpi.gpio as GPIO, and you'll need import OS. Again, with all my scripts, I have some stuff in Python 2 and some in Python 3, so we leave the option for either or here with the try except option. Then we import time, that's so we can do stuff like time sleep. Then we set GPIO warnings as false, so we're not getting all sorts of warnings when we're setting GPIOs high or low. And then we set the mode to GPIO.bcm. That's basically so we can turn relays on and off through the GPIO ports. And we come down here and we set our pin list. That tells which pins we're using for this program or which pins are available. I have an 8 relay board in the greenhouse. For this script, we're only bringing in the relays that I've been using so far on there. That pin list is just telling which pins on the Pi are the pins we're going to use. And then come down here, we start a loop. Basically, rather than have this check temperatures very frequently, I've set it for a 30-second time. And actually, realistically, you could probably check this every 10 minutes. I just like a script that turns around faster, in part because it's easier. If there's a problem with the script, I can see, inside of a minute or so if it's failing or whatever. If you have, a 5 or 10 minute sleep period before you start your script, obviously it's going to be a long wait to see if the script is working or not. Of course, you can change that temporarily or whatever. But so we're opening a loop with while true, and then I'm just printing out to the terminal display for when you're testing the script. What we're doing inside the script. And we're calling time.sleep, and we're sleeping for 30 seconds. Then we come down here, and like in the previous instance, we're going to define read temperatures from the one-wire temperature sensors. So let's define read temperature device. And then we basically grab the data from the temperature sensors from the directory sysbus w1 devices, and we concatenate the address of the device in there, and then we split that out to a text file, and then we kind of go through the text file and pick out the characters that are in the text file returned from the temperature sensor, then come down here and we convert from Celsius to Fahrenheit here, basically returning a temperature back for each sensor. So this part of the script sets us up for this next part where we define variables. For example, hot 3, we read the temperature on the address of, read the temperature on this sensor whose address is 28-01191F08E6AE. So to find these addresses, you can go into your terminal and just do ls space sys bus w1 devices, just like you see up here. That's the directory you're after. So we grab a reading from that temperature sensor, and then, as with all my scripts, I like to see whether or not we're reading the sensor, what the temperature is, that sort of stuff. So we go down to the next line and we print it with a print, hot 3, telling us that we're looking at hot 3, and then calling the variable that we just declared here and printing out the value of that variable on the line. Okay, so this is just a quick visual representation of what's going on here relating to the code. This is the large thermal mass on top of the stove, and that is the large 275-gallon thermal mass tank. And inside of the thermal mass on top of the stove is a copper coil. That is a wort cooler, and it is connected to 2 lines, one input, one output. Input coming from the pump, which pumps from the bottom of the reservoir where the water is coldest through the coil and delivers the hot water back onto the top of the reservoir when it's running. And this is the pump. I will put a link to the pump. It's 12 volt, I think it's like 11 liters a minute, so it's around 3.5 gallons a minute pump. I think it's rated to 130 degree Fahrenheit. It's submersible, and I think it was like 25 bucks on Amazon. There are also 2 sensors here, a high and a low. These are DS18B20 one-wire sensors. And there is a sensor on the thermal mass on top of the stove as well. Apologize for horrible lighting right here. And so that's what we're comparing and using to turn the pump on and off as we accumulate heat in the thermal mass on top of the stove, and then we trip the pump on accordingly and pump that heat by circulating water into the large thermal mass tank. You'll see a little bit better once we get down into this. So then we grab temperatures for the large thermal mass. That's the 275-gallon tank. There's 2 sensors in that, a high and a low. We grab those. We calculate the average temperature in that tank so we can calculate BTUs more accurately in the tank. So we go Tmass average, and we look at the high and the low. We add those together. We divide by 2. Now we have an average temperature of the large thermal mass tank. Then we're looking to determine what the how many BTUs are actually stored in the tank. I use 60 degrees Fahrenheit as my default. So if the tank is at 60 degrees average, then we have 0 BTUs in storage. Anything above that, we have BTUs in storage. Anything below that, we're at negative BTUs. And that way I can see, if the greenhouse goes below 60, that's not really ideal for the greenhouse. So that's why I'm using 60 as a reference. Depending what you're doing, you may set this differently. If you had a garage and you didn't care if it went below 40, then you might set 40 as your 0 value. Anyway, we go down and we calculate what the BTU in the large thermal mass is. We do that by taking the volume of the thermal mass we're working with and multiplying. So in our case, we have a 275-gallon tank, and actually it's about another 10 gallons to really top that up completely. So I use 285 as my value, and for every gallon we're looking at 8.33 pounds of water, and that's where we get that number 2374. So that's 2,374 BTUs for every 1 degree in Fahrenheit rise or fall. Just so you know where the number is coming from here. And then of course we print that back out to the script so we can see what the actual values are. Then let's see, I used to have 2 different sensors on the hot thermal mass on top of the stove. I now only have 1, but I left the hot average in here because I probably will add a second sensor back at some point. But for now, we're basically just looking at the average of hot 3, which is the same as hot 3. That's the first value we called up top there. And then we're looking at the, again, just like we did with the large thermal mass, we're doing this with a small thermal mass on top of the stove. We're calculating against the 60 degree Fahrenheit value to figure out how many BTUs over our 0 value in BTUs we are. And in this case, we're using 125. That's based on the volume of that tank, or the volume that I have in that tank. Let's look at that quick. So we're calculating based on a 15-gallon value here. Of course, I print those out again. Again, so when I'm running the script, I can see what's going on. The other thing I get in here is stove temp, because that's handy when you're doing remote script work, or you just want to know when you're testing the script, or if you go in through SSH and you're not on site, you can see what the stove temperature is and see whether or not the stove's running, that sort of thing. Just nice to have some of these other values printed out in the script when you're working. Let's see, then we have hot average and Tmass average. We basically declare those values so we can compare down below here. And then we use D heat is the difference between the hot thermal mass and the large thermal mass, and then that tells us whether or not we need to turn the pump on or off. So D heat is the is the small thermal mass temperature minus the large thermal mass temperature, and then that gives us a delta or difference between the two. And then we come down here, and again we're using the print statements here and actual values declared in the variables, just to print out what this script that's below down here, just to print out what that's doing. So when you look at the script, you know why the pump should be on or why it should be off, that kind of thing. So then here's the important part of this, as far as turning the pump on and off. We use an if, else if statement. So it's if, elif, and so if D heat is greater than 20 and the H average is greater than 120, so it's the difference in temperature between the thermal mass on the stove and the large thermal mass is greater than 20 degrees, and the average temperature of the thermal mass on top of the stove is greater than 120 degrees. We set the GPIO, GPIO.setup, pin 13, GPIO out. We're setting the GPIO to tell it that we're sending an out command rather than trying to receive a signal in. And then we go GPIO output for pin 13, GPIO.low. We're setting the pin low, and that turns the pump on. That trips the relay on, which brings power onto the pump. And of course, when we do that, we want a print statement to tell us that the pump is on. So that's why we do print colored pump on green. And so print colored, and then inside the parentheses here is the statement that will print out in the script. And then because we're using print colored, you have to specify what color you want that to print out in. And that's why we use the single quote and green single quote after the comma, just so you can see what's going on there. Then our second part of this if, else if statement is elif, D heat is less than or equal to 20 degrees, or the hot average is less than or equal to 110 degrees, then we switch the other way and we set the GPIO to high. So same kind of thing, GPIO.setup, pin 13, GPIO.out, making sure that the GPIO knows that we're setting an out, we're using GPIO to control something externally rather than trying to collect data through it. And then GPIO.output, pin 13 again, then we set it to GPIO.high. That sets the pin high, which turns the relay off. And then finally we print colored pump off in red. So pretty simple statement, pretty straightforward. not a whole lot more to it. So what I'll do here real quick is I'll close out of this, and I'll just run the script quick, and you can see the script actually runs. You can see what it looks like when it's running. So you can see we're waiting 30 seconds in that time sleep up front. And then after 30 seconds, you'll see all the temperatures, BTU values, all that kind of stuff spit out on the screen. And then you'll see the script make a decision based on what the actual values are in the thermal mass and the large thermal mass. And that's that. So I might trim this down just to save you from having to wait, or I might not. So there you go. You can see it checked the temperature, and obviously the D heat is 13.72 degrees and the H average is 103 degrees, so we shut the pump off, and the pump will stay off until it goes the other way. And the way the script is set up, this is a continuous loop. You could do this differently and not run a loop with if-else-if statements, and you could actually run it through the cron tab. But I like the loop, and you know, it's just one way of doing it. That's the way I've chosen to do it. And you can see actually that the stove must be running pretty well right now, because went from 13.72 to 14.06 degrees in 30 seconds out there. And so you can see the script will keep running on through. And I guess I'll just pull the live chart up here quick, and you can see, yeah, the stove is cranking along pretty good. I know that's 83 degrees Fahrenheit, but what I'll do here is insert a shot of how this system is set up, and you'll see that the sensor for the stove is about 6 or 8 inches off the side of the stove, so that's why it's not reading, you know, in hundreds of degrees. Also, you can see this is D heat here, and you can see that's climbing again now since I shut the pump off to do this video. And let's see, we'll look at the thermal masses quick here. There you go, that's BTU3. That's the hot mass on top of the stove. You can see that sitting about 13,000 BTUs. That's the other two masses we're seeing here, BTU3. Come on. Tell you what we'll do. If I can get into it. I can't. Anyway, so you can see that's sitting around 13,000, and then this is the large thermal mass up here, and that's sitting around 72,000. And I've actually got the pump switched over to heat shower water for the greenhouse right now. So we're heating another barrel. So that's why you're not seeing a rise in BTU temperature right now. But like you can see last night where I ran the stove and this script was running, you can see D heat climbing because I had it shut off. And then when I started the script back up again, you can see D heat drop rapidly, and you can see the large thermal mass taking on heat. And as a confirmation of that, you can see that the thermal mass average temperature climbed pretty rapidly here from, I don't know, when we started up we were looking at about 105 degrees, and just in the first stove cycle we were up to 113. So just a kind of a visual reference to see how this all works. All right, I will insert a clip of the actual physical parts of this in the greenhouse somewhere in this video, and when my friend Aaron gets his forum back online, I'll publish this video and we'll post the code on there as well. So look for links in the description for that. I hope someone found this informative or useful. Thanks for watching the Pharmacy Seeds Network. Don't forget to like, subscribe, and share. Hope we'll see you in the next video. Thanks for watching.